speedier than the surface of space-time can remain mindful of it, and it'll essentially tear.
I'm scared by this.
At this point, our night sky is changing rapidly, and in a question of numerous years, while perhaps not sooner, it might end up being absolutely unrecognizable. Cosmologists, generally speaking, are sounding the alarm. Experts like Neil deGrasse Tyson have confirmed the unavoidable impact of Polaris, and the story behind it is exceptionally surprising. Polaris, known as the North Star, has for some time been a constant in our night sky, serving as a crucial reference point for stargazers, guides, and space specialists. However, this could soon change, altering our night sky and cosmic assessments. How about we delve into the significance of this danger and its implications for all of us? Join us as we uncover the story of Polaris as it moves toward its end. For a significant period, Polaris has guided mariners and stargazers alike, standing firm as a revered beacon. Its unfazed presence in the night sky has been crucial for navigation. However, this reliability may soon be disrupted. In September 2023, a research paper presented by the respected Royal Astronomical Society cast doubt on the fate of this celestial entity. Polaris is close to the shaky edge of exploding, potentially vanishing from the night sky entirely. Before we explore the results of this revelation, we should learn more about Polaris, otherwise known as the North Star or Pole Star. Polaris is unique due to its proximity to the celestial North Pole, positioned directly above Earth's North Pole. It appears virtually fixed in the northern sky, located in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a relatively bright yellow-white supergiant star, much larger and brighter than our Sun. It is not a single star. Rather, it is part of a complex triple star system, with Polaris A and Polaris B forming a double pair, while Polaris B orbits around them. The interactions among these stars create gravitational forces shaping their orbits and influencing their behavior. Any disturbances in these relationships can lead to irregular variations in the star's brightness or pulsation patterns. However, the specific mechanisms behind these relationships remain complex. Polaris is located about 323 light-years from Earth, meaning the light we see from it today began its journey quite some time ago. Hence, if Polaris were to explode now, we wouldn't see it until over 3 centuries later. It's even possible that Polaris has already exploded, and we have yet to notice the light from that event. Throughout time, the North Star's held immense cultural, navigational, and symbolic significance. Its stability and fixed position made it a valuable guide for ancient mariners, leading them across seas and lands. Symbolically, Polaris represented steadfastness and direction, remaining constant amidst the ever-changing night sky. For cosmologists, Polaris served as a vital reference point, assisting in the study of celestial movements and variable stars. As a Cepheid variable star, its occasional variations in brightness have provided significant insights into stellar properties and the nature of variable stars. This characteristic also played a crucial role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, which has been the norm for the star, simplifying it for us to anticipate its behavior. However, Polaris has wandered from this typical pattern of behavior. This peculiarity in its pulsation cycle has puzzled astronomers, prompting a closer examination of this celestial inconsistency. Instead of its expected uniform pattern, Polaris has begun showing unusual patterns of dimming, raising concerns among scientists that the star may be nearing the end of its life. This aligns with behaviors commonly observed in stars approaching their demise. The gradual increase in Polaris' pulsation period, which was once consistent, can be attributed to interactions within its star system. We have observed an annual increase in the pulse length of 4.5 seconds. While this may seem insignificant, it holds substantial implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more alarmed, believing that the star is close to the dangerous edge of exploding. The similarities between Polaris behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited perplexing anomalies in their luminosity, raising concerns about potential explosions, as stars in their late stages often show such anomalies before reaching the end of their life cycles. NASA has expressed raised concern about Betelgeuse. However, formal attention has not been directed toward Polaris. As a Cepheid star approaches the end of its life cycle, it progresses through various stages, including the main sequence stage, red giant stage, and finally, the supernova explosion. Considering Polaris' inconsistent pulsations, analysts predict it has entered the helium-burning phase, typical of giant stars nearing their end. These anomalies in Polaris behavior align with patterns indicative of supernova stars in their late stages. However, compelling evidence of its impending supernova remains elusive. Astronomers are diligently examining these irregularities to grasp Polaris' fate. If Polaris were to somehow go supernova, it would likely be a monumental event in our sky, potentially overshadowing the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance could drastically change, momentarily altering our view of prominent star groups like the Big Dipper or Ursa Major, of which Polaris is a part. Rest assured, Earth would likely be completely safe, whether or not Polaris were to explode, given its mass and distance from us. While a Polaris explosion might not be visually staggering like that of Betelgeuse, it could still be noticeable to the naked eye for an extended period and outshine nearby stars. Cosmologists and observatories would undoubtedly pay attention, igniting interest within the academic community and among stargazers in general. However, the specific visibility and impact on Earth's atmosphere or environmental factors would be less critical compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? We should clarify one thing. While giant stars typically end their lives with a supernova, this is unlikely to be the case with Polaris. When a massive star goes supernova, a tremendous explosion occurs within it, marking the final catastrophic stage of its life. This cycle involves a complete collapse of the core, triggering a massive shockwave that causes the star to detonate violently. However, Polaris is not massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and evolve into a white dwarf. This transformation will not result in a supernova, but rather a tranquil end as it becomes a small, highly dense celestial remnant. A white dwarf is the remnant of a low or medium-mass star that has depleted its nuclear fuel. It is incredibly dense, potentially as massive as the Sun, but compacted to the size of Earth. When this happens, we will no longer be able to see its remnants from our planet, unlike how we see the star today. Contrasting the typical effects of Polaris explosion with historical supernova events provides valuable insights into the evolution of stars and their ultimate fates. Comparing our expectations from observable supernova events like SN 1987A and later events, such as SN 2011 Fe or SN 2014J, offers significant information for understanding the potential outcomes of Polaris explosion. For example, SN 1354 resulted in the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across various frequencies, offering astronomers a rich field for study. Similarly, SN 1987A, located in the Large Magellanic Cloud, provided insights into the patterns of nucleosynthesis and the properties of supernova remnants, including phenomena such as the formation of nebulae and the release of massive jets and variations in luminosity, which can provide insights into Polaris' unique characteristics. The formation of clouds like the Crab Nebula results from the ejection of material during the supernova explosion, which then interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Moreover, the release of massive jets and high-energy particles propelled rapidly by supernova shock waves has implications for astrophysical processes and cosmic radiation conditions. To draw a definitive comparison, astronomers assess differences in the mass ejection and speed of expelled materials between Polaris' expected explosion and other observed events. This includes studying the light curves, spectra, and remnants from these events and extrapolating similar characteristics for Polaris anticipated explosion, evaluating whether Polaris explosion might lead to the formation of nebulae or significant primordial distributions. Another significant area of study involves evaluating the pulsational variability of stars nearing their end stages compared to Polaris against observed supernova precursors. This comprehensive analysis can help estimate similarities or deviations and provide insights into the explosion mechanisms. Pulsational variability in stars nearing the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Regardless of meticulous observations and extensive analysis, astronomers find themselves puzzled by the future of Polaris as researchers delve deeper into the complexities of Polaris and its potential fate. They face a multitude of challenges. The behaviors of stars, especially those in unique systems like that of Polaris, are influenced by intricate gravitational interactions and stellar processes that are not yet fully understood. This makes predicting the precise timing and nature of any explosive event or transformation exceedingly difficult. The prospect of Polaris going supernova is further complicated by its classification as a Cepheid variable star. This designation signifies that Polaris undergoes regular pulsations, leading to variations in its brightness. While these pulsations have provided invaluable data for astronomers in the past, the recent irregularities complicate efforts to understand its life cycle. The observed changes might indicate that Polaris is experiencing significant internal shifts that could foreshadow its eventual transformation. In addition to its immediate astronomical implications, the fate of Polaris poses broader questions about stellar evolution and the life cycle of stars. By studying Polaris and its behaviors, scientists can glean insights into the processes governing massive stars and the eventual fate of similar celestial bodies. This understanding can also enrich our knowledge of how stars contribute to the chemical enrichment of galaxies, influencing the formation of new stars and planetary systems. Moreover, as Polaris continues to change, its role in the cultural and navigational context of humanity may also shift. For centuries, it has served as a reliable guide for travelers and explorers. If its brightness diminishes or it disappears entirely, it could have symbolic ramifications, altering humanity's relationship with the night sky. Despite the uncertainties, astronomers remain hopeful. The study of Polaris not only enhances our understanding of this particular star, but also contributes to the broader field of astrophysics. Continuous monitoring and advanced technological tools allow researchers to track these changes in real time, potentially unveiling new phenomena that could reshape our understanding of stellar life cycles. In summary, the ongoing investigation of Polaris reflects the dynamic nature of the universe and the ever-evolving understanding of cosmic phenomena. As scientists observe its peculiarities, they remain committed to unraveling the mysteries surrounding this iconic star, hoping to answer the pressing questions about its future and its implications for our own understanding of the cosmos. The fate of Polaris, whether it leads to a quiet transition into a white dwarf or an explosive finale, is a captivating chapter in the story of the universe that continues to unfold.